on lock pins pulled.
And we just heard the poll with all stations reporting that they're go for launch. Alyssa, we're entering the final few minutes of the count here, about 5 minutes and 45 seconds.
Okay, I believe we are live.
Tell me,
This is really cool. Bear with me.
ULA is always excited about doing.
Let me mute this audio real quick. We have got a live. This is the live launch of the Parker Solar Probe. This is so cool. A while back in April, I think was the cutoff, you could actually get your name entered to be put on a flash drive to be sent to on the solar probe to the sun. This is a NASA mission to make the trip basically to touch the surface of the sun. My understanding is this is basically a suicide mission, but it looks like we've got about 4 minutes until launch. They've already cleared all of their safety checks to make sure they're clear for launch. This launch has been postponed several times since they first tried to set it up, but this is fantastic. And we're going to go ahead and turn the audio back on here so you can hear the commentary from the live stream. But this is absolutely amazing, and I love this. And I was able to get my name and unexpectedly random listed on that flash drive that's going to touch the sun. This is a fantastic opportunity for us as far as our space exploration goes. So we're going to go ahead and turn the audio back on, and we'll listen in.
And we'll pick up the count. 5, 4, 3, 2, 1.
T-minus 4 minutes and counting.
All right, they are down to 4 minutes until lunch. Lunch, not lunch. So this is insane. I absolutely love this. And I am streaming from my phone because I had no other way to pull this off. It was, to be completely honest, I'd been keeping up with it for a while, and then I'd forgotten about it. And with the postponements and stuff, I wasn't entirely sure
And once again, 25.
when they were going to be launching.
About 3 minutes and 20 seconds before liftoff.
But this is the greatest thing. I don't know if you can hear the audio there.
What we have left to go in the next 3 minutes.
Yeah, the teams are securing blocks and LH2, liquid hydrogen tanking there. They'll be finishing that up, getting ready to go internal. You'll hear a call for spacecraft power to internal. They'll be arming their flight termination systems and getting ready for launch, and then bringing the Delta IV Heavy launch vehicle onto internal power to prepare for the final terminal count.
It's 2:49.
And we are coming up very shortly.
The cloud you see, well, as you see, they've stopped, which I believe means they've locked down the fuel and cooling systems. But the gas you've seen coming off from the shuttle itself, that was either the hydrogen cooling system or vaporized fuel, because they use a liquid fuel. I love this, and to be part of it. I mean, even as separated as we are here, this is of course launching from Cape Canaveral in Florida, and I'm in the middle of landlocked Kansas.
And we are at T-minus 2 minutes.
We're just
5
approaching
seconds and counting.
T-minus 2 minutes.
After liftoff,
2 minutes
we'll be
until
listening
launch.
To the voice of United Launch Alliance, Patrick Moore, providing ascent commentary.
And this
1:55.
is a completely unmanned mission, to my understanding. It's a it's a probe, a space probe called the Parker Solar Probe. Their goal is to touch the surface of the sun, essentially. They've got all kinds of monitoring systems in place, and they've done extensive testing on the heat shielding that this system is going to need to actually be able to reach the sun.
FTS armed.
I don't know right offhand how long it'll take to reach the sun.
1:20.
I assume it's going to take several days at the very least, but I don't know right off the top of my head how long it's going to take to cross I believe it's 3 planets between here and the sun. So this is really fantastic.
1 minute.
1 minute until launch.
Rock, report range status.
Oh, this is
50.
so cool. 47 seconds to launch.
LTOVM. They're go for launch. Richard.
They are go for launch.
Secure flight level. 40.
Oh, this is so awesome.
Minus 30. Status check. Go Delta. Go PSP.
Here we go. You'll see they're coming down to about 20 seconds, I believe.
Minus 15.
15
Go to
seconds.
ignition.
And there's, see at the bottom there,
10.
they're igniting.
9. Mr. Start.
8, 7, 6, 5,
4, 3, 2, 1.
0. Liftoff of the mighty Delta IV
We have
rocket
liftoff.
with NASA's Parker Solar Probe.
Oh, this is so
a daring
cool.
mission to shed light on the mysteries of our closest star, the
Oh,
Sun.
look at that thing go.
Look good in full thrust mode.
Looks like they got 3 primary thrust engines to get it out of the atmosphere.
25 seconds into flight. Chamber pressures continue to look good on all 3 boosters.
Pressures are looking good. Oh,
Now 35 seconds in. Chamber pressure on the core booster is
look at it go.
partial thrust mode. Response looks good. Now 50 seconds into flight.
Almost a minute into the flight.
Looking good in the full thrust mode.
Let's see if I can zoom in here a little bit on
Partial
this.
thrust mode.
As you can actually see the lights from the 3 separate engines.
Eagle trajectory looking good right down the middle of the range track.
Trajectory is good.
1 minute,
They're
10 seconds into flight.
right on target. Just over 1 minute into the flight. Oh, this is so cool.
Coming up on 1 minute, 19 seconds into flight. Max Q, maximum dynamic pressure, and Mach 1, Delta 4 is now supersonic.
They've hit Mach 1.
1 minute, 30 seconds into flight.
And I looked,
Port and starboard booster engines continue to look good in the full thrust mode. Port
Engines-
booster looks good in the partial thrust mode.
engines are looking good. Everything's going according to plan. They mentioned they were at
45 seconds into flight.
max dynamic Q, or max dynamic pressure and max Q. Those are referring to the
Trajectory continuing to
pressures
look good right down the middle of the range track.
and the forces upon the engines actually as they're taking off, if I remember correctly, which is
ATS pressure.
amazing. There's so much that goes into a launch like this, and this is uncharted territory. They have
2
never
minutes, 10 seconds in.
done what they're
Strap-on boosters continue to look good in the full thrust mode. Core booster looks good in the partial thrust mode.
doing today. Sounds like the outer engines are still at full
And Delta
thrust,
4 has gone to closed loop guidance.
and they have dropped the center thruster to partial thrust.
2 minutes, 30 seconds into flight.
2.5 minutes into the flight, and we are still soaring wonderfully. This is great.
2 minutes, 39 seconds into flight, the Delta IV rocket now weighs just 1/2 of what it did at launch, burning propellant at a rate of almost 5,000 pounds per second.
It weighs half of what it did at launch. That is insane. Just 2.5 minutes into the
And launch vehicle is now 33 miles
Flight.
altitude, 49 miles downrange distance, traveling at 4,500 miles per hour. 3 minutes into flight.
it's madness.
R-68A engines in the port and starboard boosters continue to look good in the full thrust mode. Core booster looks good in the partial thrust mode.
All thrusters are doing great.
3 minutes, 15 seconds into flight.
Oh, this is so cool. I love it.
Trajectory continuing to look good down the middle of the range track.
Everything's going good. I really hope,
Approximately 2 minutes remaining in the boost phase of flight.
and I don't know if they will.
Pressures continuing to look good on all 3 boosters. Port and starboard booster in the full thrust mode. Core booster continuing in the partial thrust mode.
I watched a
And standing by for a strap-on booster throttle down momentarily.
resupply
Port
mission
and starboard boosters have begun to throttle down.
for the International Space. Ooh, puff. That was as they were throttling down.
And we have jettison of both strap-on boosters.
The 2 boosters on the sides have just been launched.
Core
They've-
booster is throttled back up to full thrust.
core booster. It's got one engine now powering it, to my understanding, and the two side engines have been disengaged. So what I was saying, I was watching a
4 minutes, 25 seconds into flight.
resupply mission for the International Space Station, and they actually had cameras
Upper stage lock system has begun boost stage chill down sequence,
on the shuttle, so you could see
and 1 minute remaining in boost stage flight.
as each segment of the shuttle separated, and you could actually see inside the
And
rocket.
upper stage fuel system has begun boost stage chill down.
But that was through SpaceX rather than through NASA. But this is awesome. We are literally part of history. We are making history again
5 minutes into flight.
in
Just over
2018.
30 seconds now remaining in first stage phase of flight.
30 seconds left in the first stage flight.
Core booster engine continues to look good in the full thrust mode.
And I apologize if
Fuel
me
trajectory continuing down the middle of the range track.
repeating things are getting annoying,
5
but
minutes, 20 seconds into flight.
I'm not sure how well you can hear it. 5 minutes and 20 seconds into the flight.
And standing by for core booster throttle down momentarily.
And I believe it's Patrick Moore that is providing
Core
the
booster has begun to throttle down.
commentary that we're listening to on this stream.
And we have MECO booster engine cutoff standing by for stage set.
Okay, sounds like stage 1 has
And we have
completed,
good indication of stage separation.
and they
Engine
are
deploying.
setting up for stage 2. And this looks like a rendering
Start on the URAL-10.
of what's happening.
And we have ignition on the URAL-10 engine. Engine chamber pressure looks good.
So the second stage engine has fired properly. Pressure's good. Everything's going according to plan.
And we have good indication of payload fairing jettison.
Oh, that's so cool! They have confirmed that the probe has separated from
Now
the
6 minutes, 20 seconds
fuselage.
into flight.
6 minutes and 20 seconds into the
And
flight.
with the boost phase of flight complete, Parker Solar Probe will now continue its journey to the sun.
And there she goes. She is heading off into the sun. Oh, this is so amazing.
And it's 6 minutes, 50 seconds into flight.
Approaching 7 minutes.
RL-10 chamber pressure looks good. Seeing good responses on the upper stage RCS system.
This is
And after a brief
Amazing.
review of booster performance, seeing very close to nominal performance on the booster.
well, the boosters functioning as just as they could have expected, according to plan. It's reaching.
And this first burn of the second stage will last approximately 4 minutes, 42 seconds. Now 7 minutes, 30 seconds into flight.
It just crossed a
About
velocity
3 minutes remaining in the
of
first burn.
15,000 miles per hour. That rocket is flying at 15,000 miles per hour. And of course, this is a rendering of what we would be seeing if they had footage from space. It's so cool. My understanding on this, their ultimate goal is collecting more information about the sun. There's so much that we don't know about our own solar system. We've been expanding out. A year or two ago, we finally made our probe past Pluto that they had sent out many years ago. Got some amazing pictures.
And at 8 minutes, 30 seconds into flight, RL-10 chamber pressure continues to look good. Seeing very stable values on the upper stage LOX and LH2 tanks. ACS storage bottle pressure looks good. And vehicle body rates are very smooth.
Sounds like everything is going according to plan. Fuel and pressure and everything is a-okay.
Now 9 minutes into flight.
We're 9 minutes into the flight. Oh. This is so cool. I was going to do a live stream here on Twitch, but by the time I got back and set up, there was no way I was going to get my Twitch stuff set to roll, so we're just live streaming it straight to YouTube. Which is fine. This is great. I'm going to probably right here, actually I guess I can't because this is difficult to do with my live streaming software.
At 9 minutes, 40 seconds into flight.
I wanted to put
Just
a...
under 1 minute remaining now in the first burn of the second stage. Second stage continuing to perform nominally. Propulsion engine performing well. Tank pressures look good. Vehicle body rates remain smooth.
about 1 minute left on this first burn. And then they'll
10 minutes into flight.
kick in the afterburners, so to speak. They're currently at hitting 16,000
And about 30 seconds remaining in the first burn.
miles per hour. 30 seconds remaining on the first burn. So here we go. We've now moved up to the upper right.
And standing by for MECO
Side.
1 momentarily.
This is so cool.
And we
Helen,
have MECO.
and I believe when he refers to MECO, that is
Body rates smoothing out nicely.
their secondary.
And now seeing upper stage ACS firing as expected. Now 11 minutes into flight.
Don't quote me on that because I may not be accurate on that.
And this will be approximately a 13-minute coast duration prior to MES 2.
So it sounds like they're going to be coasting for about 13 minutes.
From the Mission Director Center, I'm joined once again by Alyssa Macbeth of United Launch Alliance. For those of you that are watching, we had an on-time liftoff today of the Delta IV Heavy rocket. And Alyssa, can you tell me how the launch went?
Oh my goodness, that was a beautiful launch. Just the sound and everything. Oh, it was great. It's looking good so far too. We saw good separation of the boosters from the main core and the booster from the second stage. Just experienced MECO 1. There's going to be 2 burns of the second stage, so that's coming up, the second burn, second engine start. And then in just approximately 45 minutes, we'll see payload separation. So everything's looking good so far.
Great, and can you tell me a little bit about your experience working with ULA and what it's like to work in a mission like this again?
Yeah, so I get to work with the innards of the rocket, the electronics, the avionics boxes, ordnance, pyrotechnics, all that kind of stuff. So
I'm gonna see if I can get this in a
this is something really special.
bit of a
to be able to
tripod
get
here.
your hands on a vehicle like this and do something that's going to affect the world is really, really amazing.
Well, thank you very much again for being with us, and I think we'll talk to you a little bit later in the broadcast. Thank you, Alyssa.
Sounds good. Thanks.
Sorry about that. See if I can zoom out. And then, in case I need to run somewhere, we'll get you
And
a...
at 13 minutes into flight, Delta IV upper stage is continuing the coast period prior to MES 2. Vehicle systems all performing nominally during this coast, seeing periodic thruster firings as expected. Tank pressures and body rates remain stable.
There we go. There's a little bit of glare from the light. But that'll, in case I need to get up over these next 45 minutes, 40-some minutes.
And a brief review of the performance from the first burn, seeing a fairly close correlation on major orbital elements.
Let's see if I can fix this glare.
Performance appears to be pretty good.
There we go. And that only kind of fixed it. That'll work.
From the Mission Director Center, once again, we had an on-time liftoff of the Delta IV Heavy rocket. On your screen, you were seeing a live telemetry view animation of the rocket on its flight path. So things are looking pretty good at this moment as we're in a coast phase right now. And we'll go back to Marie Lewis for more on NASA's Parker Solar Probe. Marie?
All right, thanks, Josh. And I don't know about you, but here in the studio, we could feel the rocket rumble, and I know for our folks here on the TV side, that never gets old. We have Tori standing by now with a very special guest. We've been talking about him the whole show, and Tori, we can't wait to meet him. Please introduce us.
Thanks, Marie. I do certainly have a very special guest with me, Dr. Eugene Parker himself. Dr. Parker, you just watched the launch of the mission that bears your name. What was that like?
Well, I really have to turn from biting my nails and getting it launched to thinking about all the interesting things which I don't know yet, and which will be made clear, I assume, over the next 5 or 6 or 7 years. It's a whole new phase, and it's going to be fascinating throughout. I'm anticipating that the results will turn up basic information on why the corona of the sun is at 1 million degrees. That accounts for the acceleration of the solar wind. I'm just waiting for the data now, and the experts can get busy and sort it out, because there's an awful lot of data coming in, or will be a lot of data coming in. All I can say is, wow, here we go. We're in for some learning over the next several years.
That's right, so we'll definitely be anxiously awaiting that data and research. I also hear that this is the very first launch that you were able to witness with your own eyes. Is that right?
That's right. And the video, of course, has supplied all of us with images of rocket launches, but somehow when you're looking at the real thing, it's quite impressive.
Nothing compares to the real thing, I would think.
Yeah, it's a little like the Taj Mahal. We've all seen pictures of the building, what a graceful structure it is. But if you happen to be in India and stop by that way, there's the real thing, and video and paintings and so forth just don't catch it somehow. Your mind is in a different state when you're looking at the real thing.
Well, we are certainly all honored to have you here with us this morning. Thank you so much for joining us.
My pleasure.
Marie, we'll go back to you.
All right, thanks, Tori. So great to have him here on the show. Understanding the sun will give us valuable information for future space missions. Mike Riskovich from Johns Hopkins Applied Physics Laboratory is live on set now with NASA Edge's Blair Allen. Blair?
Thanks so much, Marie. Listen, I got to tell you, I'm very excited, but I want to know, did you get out and see the launch, witness it firsthand?
Oh, yeah, I'm really excited. I had to run outside, and it was an absolutely beautiful night. The shock waves rolling over you, the beautiful sight of those 3 boosters rolling in. We could see it a long way. We could actually see the burnout, which was at about T+4 minutes, so really exciting night.
Now, what you work with primarily at the Applied Physics Laboratory is space exploration. How does a mission like this, we know the valuable science that it's going to get, but how does this help other missions with regard to space exploration?
Well, this is going to be a really big deal, not just for space exploration, but people on Earth. We're going to get a lot of new knowledge, which is going to help predictions and warnings of severe solar events that can take down the power grid or other pieces of our technological society. And then as we go ever more further into space, robotically or human, it's important to be able to give better forecasts and warnings for the operators of the robotic spacecraft and the people that go there. Today we're kind of like the mariners were in a few hundred years ago, where you didn't get warnings of hurricanes, and we want to be able to provide those warnings so we can keep people and hardware safe.
Exactly, keeping our hardware safe, and all those future missions we have, and even some of our current missions will be able to help them as well.
Yes, no doubt. We try to design to withstand the harshest environment, but it's always worthwhile to have a good warning and know when you got to hunker down. And
So I do want to step in here.
Exactly. Well,
This guy here on the left that this guy's speaking to, I love his tie.
Solar Probe.
It's got the solar system on it. It's really cool. I may have to find me one of them. No, it has nothing to do with the solar probe, but I had to mention that.
Awesome. Yep. Back to you, Marie.
All right, thanks, Blair. So how do we get close enough to the sun to actually sample its incredibly hot atmosphere? It's complicated, but NASA's Tori McClendon caught up with Dr. Nikki Fox, project scientist for this mission, to help illustrate Parker's path.
Thanks, Marie. Nikki, thank you for being here. You're welcome. So there's so many fascinating things about this mission. One thing that I find particularly interesting is the unusual orbit that Parker's going to take once it launches. Can you explain that?
Yes, once we're in space, it's a very busy first couple of weeks for us. We have to get it commissioned and all ready to go because just 6 weeks after launch, we encounter the planet Venus for the first time. We use Venus to give us a little gravity assist. Basically, it's like a little handbrake turn and it focuses our orbit in towards the sun because we don't want to be dragged around in any way or influenced by the Earth's orbit. And so during our 24 orbits of our 7-year mission, we actually will do these flybys of Venus another 6 times. And each time, as you can see from this animation, our orbit is getting smaller and smaller until those final 3 orbits, we are at our final closest approach.
Speaking of closest approach, can you describe exactly how close the Parker Solar Probe spacecraft is going to get to the sun?
Yes, at our closest approach, we will be 3.83 million miles above the sun's surface. And I realize that you just thought, million? That doesn't sound very close. But you know, the Earth and the sun are 93 million miles apart. And so if I put the Earth and the sun in the end zones of a football field, Parker Solar Probe would tuck and run all the way to the sun's 4-yard line, well in the red zone, knocking on the door for a touchdown, right by that goal line.
Well, that sounds extremely close to me, so I'm sure that folks are now wondering.
So yeah, it sounds like it's going to be a 7-year mission. They're going to loop around Venus.
Between us and the sun.
This is cool.
And so it keeps everything in the main body of the spacecraft nice and cool. It kind of creates a shadow. And it has a white coating on it that was specially designed for Parker Solar Probe. Very much like you prefer to be in a white car on a hot day instead of a black car on a hot day. The heat shield is glowing and it is reflecting a lot of the sun's energy. And so the front side of the heat shield gets to about 2,500 degrees Fahrenheit, but everything on the main body in that shadow is at about 85 degrees Fahrenheit. So much like a pleasant Florida evening.
That sounds so lovely. Well, Nikki, thank you so much.
Okay,
for
so
being
it's
here
going to be a
today.
7-year mission. It's gonna whip around Venus, it sounds like, 6 times
We are
before it
coming
makes
up on
its
a
final
number of major
approach
milestones
to
in
the
Parker Solar Probe's flight.
sun.
Let's head back over to Josh for the latest. Josh.
Thank you, Marie. I'm here again with Alyssa Macbeth, and we've been monitoring the flight as it's gone so far. And can you tell us a little about where we are now and what's about to come up next?
Yeah, so as I mentioned earlier, there was two burns of the second stage. So we're about to come up on that second burn. After that, the engines will light and we'll enter that phase. And then they'll cut off and we'll enter into a coast phase right before second stage separation. Then the third stage will ignite at approximately 37 minutes into the flight. And that will be our last and final burn before spacecraft separation.
So we had a great launch on time this morning at 3:31 a.m., but there's still more work to do
There is.
before the spacecraft separates. And can you tell me what's next for United Launch Alliance?
Yeah, our team is still working they're monitoring data in the launch control room and in Denver as well as here. Just looking to make sure everything looks nominal, that the booster performed. They're probably looking at data from the booster, making sure everything looked clear and good there. And as we continue through the flight, they'll continue to do that.
Well, once again, you're looking at live telemetry feed here. It's an animated feed that you see of the second stage. When the very top of it, you see NASA's Parker Solar Probe.
And there goes the second second burn right there.
And we just have confirmation of ignition of the RL-10 engine.
So that's the second burn of the second
And
stage.
with that, Alyssa, thank you for joining us today, and thank you for a great launch.
Thanks for having me again.
Yes.
Thanks.
And we will, after this, there will be a coast period. And then following that, I believe, is when the probe actually separates. I believe.
Body rate's continuing to look good. Chamber pressure remains stable. 24 minutes, 5 seconds into flight.
It's just so amazing to think that this missile, this rocket, I guess it's not a missile, it's a rocket, a probe, it was just 25 minutes ago, it was sitting on the ground in Florida, and now it's hundreds of, thousands of miles, I'm sure,
We are at
outside of the Earth's
time of 24
surface.
minutes, 50 seconds into launch, the second burn of the RL-10 engine. You see on your screen from the telemetry feed that is updated in real time. We'll continue to monitor things as we move towards spacecraft separation, where Parker Solar Probe will then begin to unfurl its solar wings. But for now, we'll go back to Marie Lewis in the studio. Marie?
All right, thanks, Josh. The Parker Solar Probe mission is designed to collect data and study solar processes that scientists have never seen before. NASA Edge's Blair Allen spoke with mission system engineer Jim Kinnison about the unique challenges in developing this mission.
Jim, tell me, what is the Parker Solar Probe mission?
So since the beginning of NASA even, there's been a desire to explore the regions around the sun, close into the sun, to understand the processes that are going on there, how the particles coming from the sun are accelerated, how all of the energy goes out into the solar system, and even to the Earth and beyond. Parker Solar Probe mission is the final fulfillment of that vision. We'll be able to fly the spacecraft into very close regions of the sun, make those fundamental measurements by taking this approximately 10-foot long spacecraft with a nice heat shield on the front and keep it pointed in the sun to protect all of those things that allow us to make these measurements.
Why has it taken so long to get a mission like this together? Because I know this is all new technology.
So there have been some fundamental technologies that we've had to develop over the years, and there have been many people working for decades really to get those technologies in place. Some of those are things like the heat shield. Some of it is also in the area of developing the systems we need to control the spacecraft for in those regions. Parker Solar Probe is a very autonomous system and has to maintain itself without a lot of help from humans. So the ability to do that in space is really one of those fundamental technologies we've had to develop. We've also had to develop things like cooling systems for solar arrays so that we can power the spacecraft when we're close to the sun and maintain these temperatures that allow us to continue to make the measurements.
Couldn't you just use one really small solar panel for right when you get close and get all the energy you need?
So surprisingly enough, we actually do that. When we get close to the sun, we actually take those solar panels and tuck them behind the shadow of the heat shield until only the very tips of the solar array are generating power. So
That is so cool.
Yes. I should have been an engineer.
Exactly.
Because they're so close to the sun,
really awesome.
there's so
Now, I
much energy
understand
coming off the
we're
sun,
going close to
they
the
only
sun,
need a very
but
small
we're not
portion of
flying
the
to sun.
solar
How is
panels
this mission oriented to get to the sun
to actually have
before
enough power
You're
to
absolutely right.
run it.
It's actually a fairly complicated process to get there. We'll be launching a very large rocket, give us a lot of delta V, and allows us to take out a lot of the Earth's angular momentum so that we can sort of fall into the sun. But that doesn't get us there. We actually have to do a flyby of the planet Venus and use our gravity assist to take more angular momentum out of the system so that now we can make that first approach around the sun. We'll continue to make several more Venus flybys, and every time we do that, our perihelion, the closest approach to the sun, will get closer and closer to that point where we finally are seeing the science of Venus.
So how long is the Parker Solar Probe mission?
It's about 7 years to get the final set of data that we want to get. We'll be making
7-year
24
mission.
passes close to the sun in those 7 years, starting out at about 6 months for each orbit, and then down to about 3 months per orbit by the time we get to
It's so cool.
What happens after 7 years? I mean, are you going to get pulled into the sun, or could you operate beyond that if possible? Or
We will likely, at some point, run out of propellant. And propellant is the thing that allows us to correct the momentum and to point the spacecraft. Once we run out of propellant, the spacecraft will actually start rotating just because of the natural forces around the sun and the pressure of the sunlight on the spacecraft itself. And surfaces of the spacecraft which are not supposed to see the sun will see the sun eventually, and so that will have all sorts of effects that we don't really understand, and eventually the spacecraft will join the dust cloud around the sun.
See, that's why I asked the question, because Captain Kirk went around the sun and they actually went back in time. So I was just trying to find out if there was some extracurricular mission that might send you back 7 years so you can get 7 more years of data.
He had the advantage of having warp drive. We don't have that.
Something to put in development.
That's right.
So it is a
Josh
suicide
is
mission.
standing by with a representative now from Northrop Grumman. who
They'll
has a
run
big
until they
role
run
in
out of
this mission,
propellant
Josh.
too. readjust,
Thank you, Marie,
and
we're sitting here
then when they
continuing
do,
to monitor
the
burn,
probe's just going
that we
to
have here before
go
the main
under.
engine cutoff 2, which is approximately about 8 minutes and 30 seconds away for the burn of the engine. And now I'm joined by Katie Nieves from Northrop Grumman. Katie, can you tell me a little bit about yourself and what you do at Northrop?
Sure. I'm a project manager for the Space Launch Program, supporting this Parker Solar Probe team.
And can you tell me what Northrop Grumman's role is with this launch?
Northrop Grumman Innovation Systems and sector and the divisions within it have really supported this mission tip to tail. Starting with the large composite structures, basically everything white on the vehicle, the nozzles, the fuel tanks, and certainly what I'm most familiar with, third stage.
And right now you are looking at a live shot there. That's live telemetry that we're getting. The second stage engine continuing to burn, but after that, the third stage, the stage will separate, and then we'll have third stage ignition. And can you tell me what is unique about this mission from Northrop Grumman?
Sure. Every mission has its own personality and challenges.
So it looks like it's currently over the southern part of Africa.
The sun.
If I'm reading that map correctly.
So there's a couple of things to keep to take into consideration.
Just in half an hour, it went from Florida to the center of Africa.
To the Van Allen belt.
That's
so
some speed.
To create some rad tolerant electronics mass, keeping the vehicle as light as possible so that it could have the most performance is certainly a goal. And then I'm also told that this is the first third stage on a Delta IV Heavy. So those are definitely some unique aspects of this mission.
And so can you tell me a little bit more about this specially designed third stage?
Sure. Overall, it's about 7.5 feet long, and it weighs approximately 5,200 pounds. But it includes a Star 48 BV solid rocket motor. It includes flight avionics that's built on our heritage designs, which includes an onboard flight computer with navigation, adapter structures, and its own separation systems.
And so we're still continuing to monitor the burn of the second stage here, approximately 6 minutes left in that burn, and continue to talk about the upper stage. Has Northrop Grumman developed upper stages for missions before?
We have. Most recently, with the Star 48 BV, in 2013, Northrop adapted our Minotaur 4 vehicle. We added an upper stage to create a Minotaur 5 configuration for the LADEE mission that that went to the moon. And just last year, we had another Minotaur 4 out of the Cape on ORS 5 that was a uniquely designed upper stage for to perform a required plane change.
And once again, you're looking at a live telemetry feed of the spacecraft flying over the South Africa near the heart of Beastock, which is the HBK that you see on the bottom right of your screen. And so, after this burn completes, we have a couple of events that are happening pretty quickly. Can you tell me about third stage ignition? How long this burn is going to last?
Yes, the Star 48 BB motor burns for about 1.5 minutes, and it produces over 15,000 pounds of thrust, which is about 20% of the total velocity of this mission, and about 60% of the overall orbital escape.
That
energy.
one third stage rocket provides 15,000 pounds of
It
thrust.
had, most recently on the LADEE mission in 2013, and then also our TACSAT 4 mission earlier in 2011.
We just have about 4 minutes, 20 seconds left in this burn. Hey, can you talk a little bit more about how Northrop Grumman has partnered with United Launch Alliance for this mission?
Northrop and ULA have a long-standing relationship that we're very proud of, and it's got different roles depending on the mission. Sometimes we're a customer, as in the Cygnus mission to the International Space Station. Sometimes we're a vendor, as in the large composite structures that we have provided for this Delta IV Heavy mission. And in this case, we're very proud to be a partner
with ULA and NASA.
We have about 3 minutes, 35 seconds left in this burn of the RL-10 on the second stage.
3.5
We
minutes
had an
until they
on-time liftoff at
prepare
3:31
for second
a.m.
stage
Eastern
separation, I believe.
of the Delta IV Heavy rocket with the additional third stage that we're speaking about now. The second stage continues to fly in its planned trajectory.
And about 3 minutes remaining in the burn. RL-10 chamber pressure continues to look good. Second stage fuel and oxidizer tank pressures remain stable. ACS press bottle also looks good.
Under 3 minutes left, and pressures are still looking good. Everything's going according to plan.
Now passing 35 minutes into flight.
And my name is on that probe. I love it. Unexpectedly random goes to the sun. And hopefully we'll still be around in 7 years when they're getting their data back from their final approach. And we can...
And at 35 minutes, 35 seconds into flight.
We can report on that then.
Approximately 2 minutes remaining until MECO 2. At MECO 2, the second stage will send a discrete command to the third stage to begin the initialization sequence. At that point, we should expect to start seeing telemetry data from the third stage through their transmitter. 20 seconds after separation of the second and third stage, the third stage will ignite. And it will begin its 89-second burn.
Once we get closer here to the separation, I'll go ahead and straighten out the camera so it's got a little cleaner shot. So I want to know down in the comments.
Approximately 1 minute remaining until MECO 2.
Want to know down in the comments, how many of you have actually seen a rocket launch, like a space mission, NASA launch in real life? I haven't. It's something that I'd like to see eventually, if possible. But it's pretty amazing. Even seeing it here on the live feed, the live broadcast, it's fantastic to be part of it in such a small way. Looks like we're coming up on separation time.
And standing by for MECO momentarily.
Go ahead and pick this up.
And we have MECO main engine cutoff.
Main engine cutoff. So the engine has shut down and has sent its communications to the third stage, and it's now preparing to disengage so it can separate.
Now passing 38 minutes into flight. Third stage transmitter is on.
So they're now getting communications back from the third stage. And there it goes. Second stage is separated and the probe is free.
There of separation.
Third stage telemetry.
And that's the body of the second stage.
And we have acquisition of third stage telemetry.
And they're connected to the third stage. And that is inside the ULA Center, I believe. And that looks like that's in NASA. And Johns Hopkins Applied Physics
And we did
Laboratory.
see ignition on the third stage, seeing chamber pressures, seeing some periodic dropouts of telemetry.
Ooh. So it sounds like pressure's fine, but they are having some communication trouble with the third stage, which is hopefully not a problem, but I know all this stuff is very, very precise. So anytime something isn't going the way that it's supposed to, it sets...
Now 39 minutes, 30 seconds into flight.
Sets everybody on edge. And I mean, I would too. They've spent how many years working on this, preparing it, building it, rebuilding it, getting everything specially made.
Expecting to see third stage burnout momentarily. Apologize, we're still seeing some periodic dropouts of third stage telemetry. Difficult to make calls.
It's from what it sounds like, the third stage engine should be shutting down here soon. They are having trouble with the receiving the information, but from what I'm hearing, it's still functioning how it's supposed to. It's autonomous at this point, and it's running itself. So the dropouts of telemetry that they're talking about is just losing the reception of the information, the reports of what's going on, which can still be a big hazard.
40 minutes, 40 seconds into flight. Still seeing some telemetry dropouts from the third stage.
Because what you run into with that is if you're not getting the reports that something's wrong,
At this point, the third stage would have completed the burn and would be turning to the spacecraft separation burn attitude on a nominal timeline. Still looking for some data to confirm that.
So they're saying that at this point it should have cut off its primary engine for that third stage burn, and they're still waiting for confirmation from the telemetry because it's cutting in and out, I guess. But yeah, like I was saying, if you can't get the information back from the spacecraft, from the probe, that if something is wrong, then you can't correct it. You also don't have any access to it to correct in the event that something would go wrong. At this point, I'm betting everybody here is very nervous, because not only is this a historical...
Delta flight commentary at 41 minutes, 56 seconds into flight.
Not only is this a historical...
We are still experiencing some dropout of third stage telemetry, trying to confirm that the sequence of events, and we'll provide updates when that's available.
This is a historical mission, and not only that, this is huge as far as information gathering and data collection. They have so much to learn, and I'm excited for what we have to learn from this. Personally, I'm hoping they've included a camera in their equipment on this thing, which I hope they did, but it may just be data collection rather than image collection. Because this, I mean, with their loops around Venus and that stuff, it offers them opportunities to get some pretty fantastic closer shots of those celestial bodies as well.
Now passing 43 minutes into flight.
43 minutes
and,
into the flight.
For a nominal timeline for today's mission, should be expecting to see spacecraft separation in approximately 1 minute.
According to their timeline, the probe should be separating from the, if I understand this correctly, should be separating from the rocket, from the carrier, in under a minute. But it sounds like they still haven't gotten confirmation back from the probe itself, from the third stage. Since we've got a little bit of time here, I hope, Let me know down in the comments. Let's see.
And we've been informed that the third stage is providing data to a ground station. Do not have real-time data, so we will provide updates of those events as they come in from a playback.
Excellent. So that report there is a ground station that is still able to communicate with the third stage. It's not able to communicate in real time, but they will provide updates as they can get them back from that.
44 minutes, 30 seconds into flight. Still attempting to confirm occurrence of events for the third stage phase of flight.
So let me know down in the comments what.
And for a nominal timeline, should have expected to see spacecraft separation within the last minute.
What your favorite thing about space is. Just space in general, whether it's planets, whether it's the black holes, the supernovas when stars collapse in on themselves, whether it's the harebrained idea that I've been holding on to, not that it's got any validity, but the harebrained idea that maybe once we figure out travel through a black hole, because a black hole has to go somewhere. We don't know where because we've never... From the clapping I'm seeing on screen, it looks like we have confirmation that Stage 3 has separated.
Delta Operations Center. Team shaking hands.
That's what I'm gathering from this is they've had a successful separation from Stage 3, and the probe should be flying on its own, coasting on its own at this point. But we will wait for confirmation on that.
Teams in the Delta Operations Center shaking hands. Now that you've got a Launch Alliance Mission Control Room, we have had confirmation of spacecraft separation.
Yep. That is so cool! I'll give you my applause as well. So yeah, the harebrained idea that once we figure travel through a black hole will be a massive step closer to discovering time travel. Crazy harebrained idea, maybe more science fiction than fact, but just...
Action on that too, would like to confirm the spacecraft has acquired data, and we are working on a playback to get our third stage confirmation. But at this point, the spacecraft is up and happy.
Yay! He said the spacecraft is up and happy.
And confirmation of spacecraft separation there. You're looking at a live view inside the Johns Hopkins Applied Physics Laboratory where teams were just celebrating. And I'm still joined here by Katie Nieves of Northrop Grumman. And Katie, can you tell me what's next for Northrop Grumman?
Well, congratulations to the entire team. Best of luck for Parker Solar Probe. Coming up in the fall, we've got the Pegasus Icon mission right here in the Cape. We've got the Antares launch in November out of Wallops Island, Virginia. And then next year, in April, we've got the Ascent booster test here also at the Cape, April of 2019.
Well, thank you very much for being with us tonight. Enjoy the rest of your day.
Okay, thank you for having me.
But yeah, like I was saying before, let me know what your favorite thing about space is. Just space in general. What do you love most about it?
And once again, you're looking at a live view inside the Johns Hopkins Applied Physics Laboratory. We've just had confirmation of spacecraft separation, so the teams were pretty cheerful, pretty joyful in the room there. We did have an on-time liftoff of the Delta IV Heavy with the additional third stage this morning at 3:31 a.m. Eastern Time. But for now, we'll go back to Marie Lewis in the studio. Marie?
All right, thanks, Josh. In order to collect data for this mission, Parker Solar Probe is outfitted with several sophisticated instrument suites. NASA Edge's Franklin Fitzgerald spoke with project scientist Nikki Fox about the diversity of data researchers will study.
This will be cool.
You're going to be collecting a lot of science data with Parker Solar Probe. Tell us about the instruments you're going to use to collect that information.
So we have a wonderful payload that was very carefully thought about and put together to make sure that we can make all of the measurements that we really need to do to answer these groundbreaking science questions. So we have 4 instrument suites. We have a white light imager, which we call WHISPER, that is going to look around the sky and take images of the solar wind that is about to impact the spacecraft. And so it's really going to help us kind of unlock all our other measurements. We have the fields suite that is going to measure all of the electric and the magnetic fields that we want to measure, and also any waves, any signatures that happen to be embedded in the solar wind. We have the ESA suite that measures the high energy particles. So these are the kind of nasty guys that are associated with shocks and with flares and coronal mass ejections. And then, certainly not least, we have our suite that is measuring kind of the bulk solar wind. What is coming, what is hidden in the solar wind? What are all the different particle populations? What is the temperature, the velocity, the density? And so when we put all of those measurements together, we'll be able to answer our science questions.
Now, these suite of instruments, are they new, or are these off the shelf components that you use to build?
A lot of the instruments are very similar to ones that have flown before, but they are in very challenging environments. You know, for example, we've flown radio wave antennas on many missions, but not when they're going into 3 million degree material. We also have an instrument on the front of the spacecraft. I always refer to it as the bravest instrument because it takes no shielding, no protection from our amazing heat shield. It peeps out around the side. It's a simple instrument. It's a Faraday cup, which have flown on many NASA missions. But now we're asking it to work in this incredible environment. And so it is made with very exotic materials. And even though it's a simple instrument, boy, was that a challenging thing to get achieved.
Talk to me about the challenge of building that instrument to work in these extreme environments.
One of our biggest challenges is not even just the heat. So we're in 3 million degree Kelvin, and yes, that's awful and hot and dangerous. But our orbit is very much like the petals of a flower. So we go very close to the sun on one side, and then we come out around the orbit of Venus on the other, which means we go very hot and then very cold. Now, if you think of taking any material and heating it and cooling it many times, say 24, which is the number of orbits that we have, most of the time it will change its property. It will either become elastic or it will become brittle, but it won't be the same 24 times later. All of our materials have to be the same. And so finding materials that would actually be able to withstand these changes was, of course, a challenge. And then testing them. The Parker Solar Probe spacecraft will be seeing just less than about 500 times the amount of sun we see here at Earth. So 500 suns in the sky is what Parker Solar Probe will be experiencing. And so how do you test it? We actually had to build test facilities just to be able to do this. We used reconditioned IMAX projectors because it turned out that the light that they put out is very much like sunlight. And so every single thing about this mission is challenging.
Can I go back to the IMAX projectors? Well, what does that look like? How many projectors? What kind of facility do you construct this projector field to do this test?
So the original plan for this particular instrument was to use a solar furnace simulator in France. The problem there was that it only works during the day, and it only works if it's not cloudy. And so we couldn't get long runs to be able to get continuous hours and hours and hours worth of data. And so they actually constructed their own test facility. So up at the Smithsonian Astrophysics Observatory in Boston, they actually constructed basically a vacuum chamber, and then they took the 6 IMAX projectors and changed them together.
IMAX
so
projectors.
That would provide the right amount of illumination with the right amount of scattering angle for the light, the heat, and also firing particles at the same time to be able to really simulate what that instrument is going to see.
That is so cool.
Is there an opportunity for Parker Solar Probe to collect any science on its way to Venus and back to the Sun?
So our intention is to have the instruments on it as much as possible. So we will have them on for the full journey in around the Sun and the full journey out. The only time that we will not have the instruments on really is if we're doing a major maneuver on the spacecraft, or if we're sending our data down, when we need all the power to go into the system that is going to transmit the data, and so we switch off the instruments during those periods. I often get asked, are you going to do science around Venus? And unfortunately, my quick answer is always no, because whenever we are flying past Venus, that is our prime time to get our coronal science data down. And so the instruments are
So they're not going to be
planned
picking up
off
much from
when we do our Venus flybys.
from Venus.
There is one later in the mission. We actually do 7 of them. There is one when the instruments can be on, and we are excited about what kind of science we'll be able to do there. But that's a number of years away, and a few days away from launch. Everybody's focusing on the launch right now.
Where are you going for launch?
For the launch itself, I will be honestly as close as physically possible to the Delta IV Heavy, but in reality, I will be somewhere around the press building, probably looking through my fingers at the site of the Delta IV Heavy. But actually, if they let me light it, I would.
I'm sure you would.
So that's really cool. That tells us a lot more about that, what it's going to be measuring and everything that way.
As it flies through the sun's corona.
Solar Probe is a mission to explore the sun. How can it do that? Why won't the spacecraft melt? Excellent question. You can't face off with the sun without packing the right gear. This is why Solar Probe is equipped with a white shield that reflects heat off the front and keeps things cool in the back.
The heat shield is made out of a couple of different materials. One is carbon-carbon, which is a lot like the graphite epoxy you might see in your golf clubs or your tennis racket, but it's just been superheated. The inside is a carbon foam, which is just another form of carbon and is actually about 97% air. It's a very lightweight way of making a very strong structure.
Nobody likes a needy explorer. Solar Probe can take care of itself, thank you very much. And that's because it has autonomy software.
Nobody likes a needy explorer.
Behind the heat shield.
We're too far away to joystick it into place, so it basically has to always be sensing whether or not the heat shield is in the right position and correct itself if it isn't. There are these things called solar limb sensors that are just poking out of the very edge of the shadow, and if those get illuminated, the spacecraft knows, oh, I'm going the wrong direction, and can actually right itself.
Yeah, knows I'm cooking myself.
It's important to stay hydrated in the sun, even for a spacecraft. Solar Probe circulates water to keep the solar cells from overheating. It stays cool and keeps power.
Yeah, it's actually a water-cooled solar panel.
And into the radiators, and so the water warms up when it's behind the solar cells, and then cools down at the radiators, and so that heat transfer is happening a lot like the veins in your body.
Yes, you read right. Heat is not the same as temperature. Temperature is a measurement, but heat is energy transfer. This matters because Solar Probe will be visiting the sun's outer layer, the corona. Like all stars, the sun is made of plasma. How tightly packed that plasma is depends on the layer. While the sun's corona has a very high temperature, the plasma particles are fairly spread out. So even though the temperature in the corona is 2 to 3 million degrees Fahrenheit, the heat around the spacecraft is manageable.
The corona and where we're going is actually not that dense at all. There are only a couple particles. And so when we think about it, those are very hot, but we're not touching a lot of them. It's kind of like when you put your hand into an oven. And the oven might be at 400 or 500 degrees Fahrenheit, but your hand isn't at 400 or 500 degrees Fahrenheit.
Thanks to its design and destination, this cool, competent spacecraft is all set to explore. We can just sit back and chill as Parker's Solar Probe takes the heat.
Alright. I think I'm going to mute.
We are now
that.
approaching solar array deploy.
Oh, nope.
Parker Solar Probe will
We can't quit yet. We gotta see the spreading of the wings.
in the Mission Director Center to walk us through this next event. Josh?
Thank you, Marie, and we are at a mission elapsed time of about 58 minutes and 10 seconds, and as you mentioned, we are waiting for solar array deploy that could happen as early as 12 minutes after spacecraft separation. That's a live shot. Everyone gathered around inside the Johns Hopkins Applied Physics Laboratory. We are standing by for an interview with NASA's launch manager, Omar Baez. He's going to talk more about this mission and how things went tonight. So wait not only for Solar to deploy, but also to hear from tonight's
So,
NASA launch manager.
For our video, we're going to wait until the solar arrays are deployed. After we get confirmation of that, I'll go ahead and wrap up the video. If you want to check out the rest of the information, the interview with, I forgot his name, but the guy they were just talking about, if you want any of that that footage, that information, just go to the NASA YouTube page. I'm sure this will be up there after they finish up their stream. But we are waiting for confirmation that the solar arrays are deployed. What they're mentioning in that other video, the solar panels, a standard solar panel has a bunch of cells wired together, and the heat energy hits the surface of it, which allows it to convert that into electrical energy, and that's how this solar probe is going to be powered. Well, in doing that, because they are flying into the sun, which is fantastic to say, they needed a way to keep it cool, and so they've got water running through, basically being pumped through lines along the backside of the solar panels to keep their temperature regulated, so they can still make the energy they need, but they're not going to overheat and melt down or cause any of the wiring to be damaged or anything that way, which is amazing in its own right that they've managed to do that. And then the water is then pumped to a radiator, which the fascinating thing I found about that was I was curious how a radiator would work in space, because like a radiator in like on your car or the heat exchanger on the back of your refrigerator, those work because it takes the warm air or the warm liquid, like we'll use a refrigerator for example, takes the warm air, the coolant that's been heated up from the inside of your fridge, and it pumps it up through these channels that go back and forth across the back of your fridge. Well, because they're in contact with the air, it allows them to exchange that temperature off into the room temperature, and then it cools down by the time it gets back down to the compressor, so it can start the loop all over again. Well, in doing that, it has the atmosphere. It has that air to actually exchange with, but in space it doesn't. There's no atmosphere. There's no air to exchange the heat. So the only thing I can think of is because of that heat shield they have that's actually blocking the energy of the sun, eclipsing everything from the sun essentially. They said it keeps the temperature of the components around 80 something degrees, 85 I think is what they said, 87. So on the wings, if they pump the fluid out to the wings that have the solar panels on them, the solar panels are going to get hot because they're being bombarded by the energy. And that the clapping I see, you'll notice they're clapping there. I assume that is confirmation of solar array deployment. So the wings are out on the solar probe. It has freed itself from the carrier rocket, the Delta rocket, and it is headed towards Venus.
I'm now being joined by the NASA launch manager, Omar Baez. Omar, can you tell us how the mission went tonight, how the count went?
So the count went splendid today. Very boring, which is awesome for this kind of launch. We had a tough day yesterday and weren't able to get off in the allotted time that we had. And today just went completely opposite of it. Very quiet all day, and virtually had no anomalies to work, and the weather cooperated with us, and it went off like clockwork.
Can you tell me the importance of the Parker Solar Probe mission to LSP, the Launch Service Program?
So it's very important. It's been one of our most difficult and challenging missions to date in our 20-year history. We've been through some challenging ones, and I think this one tops the list on the scale of technical challenges. This one's it, and I'm very proud of the team that worked to make this happen.
and we made it happen with a very short window at the very end for us. On a vehicle, a very powerful vehicle flying a new avionics system. And it's just phenomenal to see that Delta IV Heavy take off today. And we were as close as you can get to it as possible. The energy of that vehicle, the immense size, and when you realize just how tiny the Parker Solar Probe satellite is, and you have this big vehicle around it, it's just mind-boggling. It was really nice to hear Tori McClendon interview Dr. Parker, and he mentioned there are a couple of icons in the world, and one of them being the Taj Mahal. And until you see it up close, you can't believe how big and beautiful and for real that thing is. Well, I can say the same thing about the Delta IV Heavy. Until you see it, and you see it up close, you just can't believe it. And when you do, it's just a miracle of technology. And we at NASA and the Launch Services Program are thrilled to be part of this mission.
And it's been a busy year so far for NASA LSP. And can you tell us what you have coming up next?
So, yeah, it's a very busy year. We started at 6 missions this year inside of a short period of time. We do have 2 missions remaining this year. The ISAT mission on the very last Delta II out of Vandenberg Air Force Base, and we look forward to transitioning the team as soon as they get a night's rest over to Vandenberg so they could do a mission dress rehearsal, or a mission, a cruiser, which is the tanking test of the Delta II, this coming Wednesday in preparation for the launch of the ISAT-2 mission on September 15th.
Well, Omar, thank you very much for being with us tonight. It was a beautiful launch. And we did receive confirmation that the solar arrays had fully extended.
There we go.
With that, Marie, we'll now go back to you in the studio. Thank you.
All right, thank you. So
And I think we're gonna call
this
it.
concludes our live
We're gonna call it there, and it sounds like they're calling theirs there as well. So let me turn the light back on, and we'll get flipped around, and we'll close this thing out. That's exactly what I wanted. So this has been amazing. We went from launching the rocket on the ground in Cape Canaveral, and within an hour's time, basically, the probe was in orbit, or not in orbit. It's not in orbit. Let me correct that. The probe was in space and was headed towards its orbit, or that will be around the sun and around the crest of Venus's orbit. So it'll loop back and forth around the sun and around Venus multiple times over the next 7 years. Thankfully, they did mention that they will have an opportunity. Most of the time when it passes by Venus, all their instrumentation is going to be shut down, because that's going to be when they're going to be communicating back with home base, with can't think of the name. I'm stoked. This is so cool. But that'll be when they're communicating back with headquarters, when they're downloading all of their information that the probe has collected during that time. So there is one pass that they will have around Venus to collect information on Venus, which they're excited about. Of course, everybody's focused on the launch right now, because you can't capture anything, any data or anything, if you don't get the probe up in the air, or in the lack of air, because it's in space. So everything went well. They had some communication errors, nothing hazardous, nothing problematic. It didn't cause any problems at all. And they were still receiving communications, just at a separate location, which is perfect. I'm so glad that, it was literally like 30 minutes before launch that I thought, I need to check on the Parker Solar Probe, because I made a point to make sure I got my name and got unexpectedly random put onto that flash drive that's now making its way toward the sun, because that was a big deal for me. That was something that I really wanted to be a part of. So yeah, half an hour before launch, had to scramble to get things together, get the camera set up and ready to go, and thankfully it went fantastic, and we didn't have any trouble. The broadcast was great. We got a lot of information from the live broadcasts that we were watching and reacting to here that I didn't know. I've been following the solar probe for a while now, pretty much since I had signed up for it, trying to get more information on it and learn as much as I could about the whole event. And it will be exciting in 7 years to see what information they send back from the probe, and it'll be like kind of like the Pluto mission, only it won't take nearly as long, and this is going to be probably just as exciting because Pluto was totally unexplored. Nobody had ever been there before, and this is the first time anyone's ever been to a star, really, to measure a star, because the sun's a giant star. So I am stoked. I'm very much looking forward to the information we get back from that. Hopefully the photos and stuff, like the solar wind they were talking about, that's all stuff that I'm just, it's baffling and I love it, but it's almost unfathomable to think about. But, well, it is now like 4 o'clock, I think, in the morning. 3 o'clock. Let me check my clock here. 3:41, so almost 4 o'clock. I'm so glad I was up for that and remembered to check on it. It's been amazing. So, thank you guys for watching. It's been a blast. I hope you'll watch it again. Tell your friends about it. Feel free to share the video. I want to thank NASA for having the live stream that they did there. It was wonderful. Otherwise, I wouldn't have been able to watch it at all and share my reactions with you guys. I don't know what else to say. Oh, don't forget down in the comments to let me know whether you've seen a space shuttle launch of any kind, whether it was space probe or a manned mission. Let me know if you've seen that in person, and also let me know what your favorite thing is about space. Hit that like button, and until next time, stay random.